Hello and welcome to my channel. So today let's look at question 543, diameter of binary tree. Given the root of a binary tree, return the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. The length of a path between two nodes is represented by the number of edges between them. So for the first example, the answer is 3. The diameter is from 4 to 2, then to 1 to 3. The second example, it's the diameter is 1. There is only 2 nodes. So let me, let me do some drawing. So actually the question is one point is the diameter might not be the one passing the root. It might have this type of situation, so that you have root to the for this one, the diameter actually is from this node to this node, then to this node, and then to this node, to this node. So it's actually not passing the root. So what we can do is we can create a help function getting to calculate the maximum depth of each node. That help function will do recursion on the left and the right of child, and calculate all the max depth. So the max depth is equal to the depth of the left tree of that node, comparing the depth of the right tree, then getting the max value. So if we calculate this the distance between the left and the right, and add them together, it will be a diameter for who using this node as a transition point. So the diameter is actually will always be from one leaf to another leaf. So it will always have a transition point. So we can use a global variable to keep count of the diameter. And so let me starting writing the code, and we can. Yeah. Also another point, maybe the time complexity is O(n), which n is the number of nodes in the tree, and the space complexity is the maximum space complexity is also O(n), the worst case. So if the tree is skewed, otherwise it will be the depth of the height of the tree. But the height of the tree, the worst case can be also n. So yeah, as I said, we need to have a help function. So firstly, I define this global variable and initialize this 0. Then we can call this help function max depth root, and the help function will return int, and so the base case is if the root is null, the max depth will be 0. Then we can define the left depth as and the right depth Yeah, so as I said, the answer will be we need to update the answer for each transition node, and the answer will be L plus R. So, and also the function will need to return the max of L and R plus 1. So the max depth of this we need to add the root too. That's why we need to plus 1. So yeah, this I think also we need to return the global variable. So yeah, the code is pretty simple, but the thought process is very similar to other binary tree question, which is recursion. So let's do the okay. So it's correct for the test. Okay, yeah. So this finished today's daily challenging questions. So if you have any question, suggestion, please comment on the video. Otherwise, thanks for watching. See you tomorrow.